All right, today we are diving deep into one of the most sophisticated cyber weapons ever found. We're talking about a malware framework that wasn't just built to steal your data. No, this thing was designed to reach out from the digital world and grab the controls of the actual physical machinery that runs our most critical infrastructure. We're going to peel back the layers and see exactly how this digital weapon was built to cause real-world physical chaos.
And, that is not an exaggeration. When a top-tier cybersecurity firm like Mandiant, the ones who tore this malware apart, uses language like that, you have to sit up and listen. They're basically putting this in the same hall of fame as threats like Stuxnet and Industroyer, malware that we know caused actual physical damage. That comparison alone tells you everything you need to know about how serious this is.
So what exactly is this thing? It goes by two names, PIPEDREAM and INCONTROLLER. And as we're about to see, it represents a pretty significant and frankly a pretty alarming step forward in the world of industrial cyber warfare. To really get why PIPEDREAM is such a big deal, you kind of have to look at it as the next chapter in this dangerous story. Think about it. Back in 2010, Stuxnet was like a custom-made digital scalpel, built for one very specific job. Then we saw Industroyer, which was more of a framework, but still focused on one sector, the power grid. TRITON got even scarier by going after the safety systems themselves. While PIPEDREAM takes all those lessons and rolls them into one. It's scalable, it's reusable, and it's a multi-purpose toolkit for sabotage.
And that right there is the key difference. The whole Swiss Army knife analogy is just perfect. See, Stuxnet was like a unique, custom-forged sword for one battle. PIPEDREAM, on the other hand, is a whole arsenal in a box. It's designed from the ground up to be picked up and used against all sorts of different targets, in different industries, again and again. So, okay, let's pop the hood on this digital arsenal. The real genius and, the real danger of PIPEDREAM is all in its modular design. This table just lays it all out so clearly. You've got specific tools for very specific jobs. You have MOUSEHOLE and TAGRUN. Think of these as the scouts. Their job is to map out the entire industrial process by targeting what are called OPC-UA servers. Those are kind of like the central nervous system for all the data flying around a plant. Then you get the heavy hitters, tools like EVILSCHOLAR and BADOMEN. These are the specialists that speak the native languages of controllers from huge vendors like Schneider Electric and Omron. But it all has to start somewhere. And that's where LAZYCARGO comes in. That's the skeleton key that gets the attacker from the regular corporate IT network into the highly protected operational technology, or OT network, the one that actually touches the physical equipment.
So just how powerful is this toolkit? Well, all told, its different parts can pull off 36 distinct techniques listed in the MITRE AT&CK for ICS framework. Now, that framework is basically the encyclopedia of every known way to attack an industrial system. So this means PIPEDREAM comes out of the box with the built-in ability to do nearly half of all the bad things we know how to do to industrial controls. That's a lot. So you've got this incredibly advanced arsenal. How would an attacker actually use it? Let's walk through the whole kill chain, step by step, from a normal computer on a business network all the way to physically manipulating industrial machinery. The attack follows a really clear 4-stage playbook. First, you get your foot in the door and climb the ladder to get more power. Then, you look around and start moving across the network. And all of that builds up to the final, terrifying goal, making a real physical impact. Okay, the first step is absolutely critical, and it all starts on a standard Windows machine, probably an engineer's workstation. To get across that heavily guarded bridge between the IT world and the OT world, the attacker can't just be a user on the machine. No, they need to become the machine. They need the highest level of control you can possibly get, what we call kernel-level control. And here's the really clever part. They don't use some crazy unknown zero-day exploit. They use a known vulnerability in a totally legitimate, trusted, and digitally signed hardware driver from a company called AceRock. This little flaw is the whole key. It lets an attacker write whatever they want directly into the computer's physical memory, completely bypassing all the normal security guards. It's basically a digital master key that lets them rewrite the rules of the operating system itself. The process itself is just brilliant, and it's so simple. First, the LAZYCARGO tool just drops this vulnerable but trusted driver file onto the computer. And because it's got a legitimate digital signature, Windows says, sure, come on in, and loads it. Then, the malware uses that vulnerability to inject its own nasty, unsigned code straight into the kernel.
It's this 1-2 punch that lets it waltz right past one of the biggest security features in Windows, basically becoming a ghost in the machine. So once they have that ultimate control at the kernel level, the attackers are effectively inside the OT network, and now they can unleash the rest of their toolkit. MOUSEHOLE starts scanning, drawing a map of every device and process. EVILSCHOLAR and BADOMEN go hunting for their specific Schneider and Omron targets. They can even do something really sneaky, like turn a compromised PLC, that's the little computer running a machine, into a network proxy, using it like a secret tunnel to jump even deeper into parts of the network that are supposed to be protected. And all of this leads us to the endgame, the really scary part, the physical impact. The attacker now has their hands on the virtual levers. They can cause chaos in a few ways. They can disrupt things, maybe just by crashing a controller to shut down a production line, or they can destroy equipment by uploading code that tells a motor to spin way too fast or a valve to build up way too much pressure. And maybe the most dangerous part of all, they can deceive the humans in the control room. Using TAGRUN, they can feed fake, normal-looking sensor data back to the operator screens, essentially making everyone blind to the disaster that's happening right under their noses. So the most important point here is that when you put PIPEDREAM side by side with something like Stuxnet, you see this massive shift in strategy. We've gone from these one-off, handcrafted weapons to a scalable, reusable, multi-vendor toolkit that's basically built for mass production. And this, right here, is the single most important thing to understand. The state-sponsored group that created PIPEDREAM didn't just build another cyber weapon. They built a weapons factory. And that whole philosophy makes it a much more strategic, a much more persistent, and frankly, a much more dangerous threat to infrastructure all over the world. So the big question is, how on earth do you defend against a threat this advanced? Well, the good news is that because PIPEDREAM was discovered before it was ever actually used, the defenders got a huge and crucial head start. And the answer isn't some magic silver bullet or some fancy new box with blinking lights. The key is what we call defense in depth, which is really just a strategy grounded in getting the cybersecurity fundamentals right, but doing it with a deep understanding of these new kinds of threats. Really, effective defense comes down to 3 basic ideas. First is visibility. You can't protect what you can't see, so you need to be watching for weird stuff. Second is hardening. You have to make yourself a tougher target. That means things like separating your networks and patching those critical workstations. And finally, resilience. You have to assume that one day you might get hit, and you need a solid plan for how to respond and get back on your feet. And this chart just drives that point home perfectly. Look where the effort needs to go. The huge majority of a good defense, what is that, a combined 85%, is in the proactive stuff, locking down your systems before an attack ever happens, and actively watching them for threats in real time. Being ready to respond to a disaster is critical, of course, but stopping it from ever happening in the first place is always the main goal. You know, the story of PIPEDREAM is actually a huge win for the defenders. We had incredible collaboration between security companies and governments that exposed this weapon before it was ever fired in anger. But it leaves us with this final, pretty sobering question to think about. This time, we got a warning shot. Will we really be that lucky with the next purpose-built industrial-grade cyber weapon that comes